Most students fail questions on indices and logarithms, not because the questions are hard, but because they miss one simple rule. In this video, I will solve JAMB and Post-UTME past questions step by step, explaining each stage so you can understand the method and answer similar questions confidently. If you're preparing for JAMB, WAEC, Post-UTME or whatever exam at all, you're in the right place. Let's get started. The first question we have here says, simplify the cube root of 64a to the power 3 all raised to the power negative 1. Option A, we have 1 over 4a, B, we have 8a, C, we have 4a, and D, we have 1 over 8a. Solution. The first step to solving this question is to simplify the cube root. Let's simplify the cube root. If we do that, we have the cube root of 64 is equal to 4. That is 4 multiplying itself 3 times, 4 times 4 times 4, which will give us 4 raised to the power 3. And we also have the cube root of a raised to the power 3, which is equal to a. That is a multiplying itself 3 times, a times a times a, which will give us a raised to the power 3. Therefore, the expression becomes 4a raised to the power minus 1. This expression now becomes 4a raised to the power minus 1. Now the next step is for us to apply the negative power law in indices. Applying the negative exponent law in indices, first we need to know what the negative exponent law means. The negative exponent simply means we take the reciprocal. That's what it means. A negative exponent means take the reciprocal, and in the reciprocal just talks about 1 all over the number itself. So reciprocal of any number is 1 over that number. For instance, if we have x raised to the power minus 1, if we have x raised to the power minus 1, the negative exponent simply means 1 all over x. So that is the reciprocal. Then if we apply that to the value we have above, 4a raised to the power minus 1, it will give us 1 all over 4a. Therefore, the correct option to this question is option A, 1 all over 4a. Now we have the next question. The next question is on standard form. Yes, standard form. Many students mess up a lot when they have questions on standard form. The question says, express 0.00462 in standard form. Express 0.0462 in standard form. Option A, we have 0.462 times 10 raised to the power minus 1. Option B, we have 0.462 times 10 raised to the power minus 2. And option C, we have 4.62 times 10 raised to the power minus 1. And D, we have 4.62 times 10 raised to the power minus 2. Now let's solve this together. Solution. The first step is to recall what the standard form is all about. Standard form or standard notation simply refers to expressing large numbers in the power of 10. That's what the meaning of standard form is all about. So when you hear standard form, it just means express a large number in the power of 10, or express any number at all in the power of 10. Now for us to be able to answer this question correctly, we move the decimal points 2 places to the right. I'll repeat myself. Move the decimal points 2 places to the right. If we do that, we have 0.0462 will give us 1, 2. I'm moving it 2 places to the right, so we have 4.62. Since the decimal moved 2 places to the right, the exponent is -2, negative. If you move to the left, the exponent will be a positive sign. If you move to the right, is a negative sign. So this particular one moved to the right, so our power here is -2. Therefore 0.0462 is equal to 4.62 times 10 raised to the power -2, and then the correct option is option D. 4.62 times 10 raised to the power -2. That's our correct answer. Question 3 now is a very technical question, and then you see it virtually in all exams. It says, without using tables, evaluate 343 raised to the power 1/3 times 0.14 raised to the power -1 times 25 raised to the power -3/2. Option A, we have 12. Option B, we have 10. Option C, we have 8. And option D, we have 7. Many persons, when they see this kind of questions, they are scared because they say without using tables. Now solution, let's solve these questions together. The first thing we need to do here is to evaluate each term separately. So we solve each of them separately. For the first term, we have that 343 is equal to 7 raised to the power 3. That is 7 times 7 times 7. 7 times 7 will give us 49. 49 times 7 will give us 343. So we have 343 raised to the power 1/3 is equal to 7. This is the same as the cube root of 343. Now for the second term, it has a negative power. So recall what we said about the negative exponents, which means reciprocal, right? So we have 0.14 raised to the power -1 is equal to 1 over 0.14. Since we have 0.14, if we express it as a fraction, we have 14 all over 100. 2 into 14 will give us 7. 2 into 100 will give us 50. We have 7 over 50. Then we have 1 over 0.14 is equal to 7 over 50. But we need to take the reciprocal. So the reciprocal of this will give us 50 over 7. That is that for the second term. The third term, let's move on to the third term. Don't forget, we need to evaluate each of them separately. For the third term, we have 25 raised to the power -1/2. 25 raised to the power -1/2. It will give us 1 all over square root of 25. And we know that square root of 25 is 5, so we have 1 all over 5. The next step is to multiply everything. That is the value of the first term multiplied by that of the second term and the third term. So if we multiply everything, we have 7 times 50 over 7 times 1 over 5. 7 will cancel 7, so we have 50 times 1 over 5. Something can divide through, yes. 5 can go into 5, and then 5 can also go into 50, giving us 10. Therefore, the correct answer here is 10, and 10 is option B. So from our options, the correct option is option B. Now for the fourth question, is on indicical equations. It says if 9 raised to power 2x minus 1 all over 27 raised to power x plus 1 is equal to 1, find the value of x. So from this equation, this simple equation, they said we should find the value of x. Option A is 3. Option B, we have 8. Option C, 2. And option D, 5. So solution, let's solve this question together, bit by bit, step by step. So step 1, we have to express everything in base 3. Express everything, every single thing in base 3. If we do that, we have 9. If we express 9 in base 3, we have 9 is equal to 3 raised to power 2. 3 squared, which is 3 times 3, will give us 9. And 27 is 3 raised to power 3. 3 multiplying itself 3 times. Then if we impute this into the equation we have above, we have 3 squared into the power of 2x minus 1 and 3 raised to power 3 raised to power x minus 1 is equal to 1. Now we apply the power rule. That's the second step. We need to apply the power rule. If we do that, we have to multiply everything both on the denominator and the numerator. So we have the numerator. If we multiply it, we have 4x, that is 2 times 2x will give us 4x, minus 1 times 2 will give us minus 2. So for the denominator, we do the same thing. 3x will time multiply x and we have the value. 3 will multiply negative 1 and we have the value. So that's what we have there. Hence we have 3 raised to power 4x minus 2 all over 3 raised to power 3x plus 3 is equal to 1. That's what you have from the questions. So we need to subtract the exponent. Remember, from laws of indices, when the same base are dividing themselves, we pick one and we subtract their powers. So when we subtract the exponent, we still have 3 into 4x minus 2 minus 3x plus 3. Don't forget, these are powers equal to 1. If we simplify that further, we have 3 into 4x minus 3x will give us x, right? 1x. So we have x. Now we have minus 2 minus plus 3. Don't forget, plus times minus will give us minus. So minus 2 minus this will give us minus 5 equal to 1. We use the zero power law. Since 3 raised to power 0 is equal to 1, that's from the zero power law in indices. Anything raised to power 0 is equal to 1. We have that 3 raised to power x minus 5 is equal to 3 raised to power 0. The 3 will cancel out, the base will equate themselves. So we have x minus 5 is equal to 0, x is equal to 5. Therefore, the correct option is option D. Option D is the correct option. X is equal to 5. Now we have the fifth question. The fifth question we have today is also on indicical equations, simple equations on indices. It says if 3 raised to power 1 minus n all over 9 raised to power minus 2n is equal to 1 all over 9, find 9. So it's telling us in this equation we should find the value of 9. Option A, we have minus 3 over 2. Option B, we have 1 over 3. Option C, we have minus 1. And option D, we have minus 3. So solution, let's solve this question together, step by step, brick by brick. So we have step 1. The first step, we express everything with base 3. Express everything in base 3. We have 9. If we express 9 in base 3, we have 9 is equal to 3 raised to power 2, right? Which is 3 multiplying itself 2 times. It will give us 9. If we put that into the equation above, then we have 9 raised to power minus 2n to be equal to 3 squared raised to power minus 2n is equal to 3 raised to power minus 4n, because the powers will multiply themselves. Also, we have 1 over 9 to be equal to 3 raised to power minus 2. Yes, 3 raised to power minus 2. Many persons are confused. Okay, we'll explain. 3 raised to power minus 2. Now, if we equate it, if we impute this thing into the equation that was given to us, the new equation becomes 3 raised to power 1 minus n. The new equation becomes 3 raised to power 1 minus n all over 3 raised to power minus 4n, which will give us 3 raised to power minus 2. Now, when it comes to that 3 raised to power minus 2, we have 1 all over 9 is equal to 1 all over 3 squared, which will give us 3 raised to power negative 2. So that's how we got that 3 raised to power minus 2. The next step is to divide the power with the same base and subtract the exponent. So when we divide the power with the same bases, if you observe, they have the same base now. So if we divide the power, we can also subtract the base. That's from law of indices. We have 3 raised to power 1 minus n minus negative 4n. That's what we have when we simplify the numerator and the denominator in indices. It is equal to 3 raised to power minus 2. That we got from the question. So if we simplify further, don't forget, minus minus we have plus. So we have 1 minus n plus 4n. If we simplify it, you have 1 plus 3n is equal to 3 raised to power minus 2. Now, since they have the same base, we equate the exponents. We equate the powers. The powers are equal since they have the same base. So they cancel out. 3 here in the right hand side will cancel 3 in the left hand side. So we have 1 plus 3n is equal to minus 2. We have 3n is equal to 1 will cross the equality sign to the other side. We have minus 2 minus 1. 3n now is equal to minus 3. N is equal to minus 1 because we divide through by the coefficient of n. Therefore, the correct option is option C. If you're coming across this channel for the first time, please don't forget to like, subscribe, and leave a comment on the topic you would like us to solve.